Echo. Now we will proceed to study echo. A wave, when it is reflected, then the reflected wave will have the same frequency as that of the instant wave, but the amplitude of vibration decreases. The amplitude of the wave decreases on reflection, but the speed will remain the same since it will be traveling in the same medium. When the reflection occurs at a large distance, we call it as an echo, whereas in a room, the reflection is considered as a reverberation. Reflection of sound wave will be noticed from a hard wall, from hills and valleys. The reflection from hill and valley is considered as echo, whereas the reflection from hard walls inside a room is a reverberation. We can find the distance of the reflector from the following relation: d is equal to Vt by 2. O is the position of the source where sound is produced, and R is the reflecting surface which is at a distance d. Then the upper wave is the incident wave, it is going towards that reflector, and the bottom wave is coming back. Observe the amplitude of vibration, it decreases. Let t be the time taken by the wave to travel from O to R and from R to O. The total time taken from O to R and R to O is, say, t. Then if v is the speed of the sound, then Vt is the distance travelled. But here this is equal to OR plus RO, that is equal to 2d. So Vt is equal to 2d, or d is equal to Vt by 2. Minimum distance of the reflector for observing the echo, the reflected sound. This can be calculated from the following relation. Speed of sound is 330 meters per second at 0 degrees centigrade in air. In air, the speed of sound is 330 meters per second at 0 degrees centigrade. When sound is received by the ear, it will last for 0.1 seconds on the ear. For absorbing the sound, we require 0.1 seconds. So, in this time, in this interval, in 0.1 seconds, if another sound is received, so it gets mixed with the original sound. Hence, if the echo is received in a time less than 0.1 seconds, then it cannot be distinguished. It mixes with the direct sound. So, it should be received only after 0.1 seconds. So, the minimum time that should be taken for observing this echo should be 0.1 seconds. So, we take t is equal to 0.1 and v as 330 meters and then calculate the distance of the reflector. We have the relation d is equal to Vt by 2. Substituting the values of Vt, we will get d as 16.5 meters. So this is the minimum distance at which reflection should occur so that we may distinguish the echo from direct sound. If it is received, if the reflection takes place at less than 16.5 meters, it cannot be observed clearly. If the reflection takes place at distance greater than 16.5, we can still hear the echo. Let us consider some special case. Let us consider two reflectors, and the source is in between the two reflectors, and the distance of the left reflecting surface is d1, and that of the right side reflecting surface is d2. Then when a sound is produced at S and it is received, the observer is also at S. O represents observer, S represents source. Both are at the same point. Then the time of receiving the echo from the left reflecting surface is T1 is equal to 2d1 by V. The time of receiving the echo from the left surface is 2d1 by V. The time of receiving the echo from the right reflecting surface, T2 is equal to 2d2 by V. So from this we can calculate the total distance or the total time taken at the time interval with which they are